So, hello everyone, my name is Malik Arslan Nisar and I am a TA for this course, Numerical Linear Algebra. So, this is the week 7 of the course, and today we will discuss some problems related to the course content you have studied during the week. So, is my screen visible?
It's preparing. Yes, ma'am. Now visible.
Okay. So, the first question is, let A is equal to A11, A12, so on up to A1n, and column wise it has, row wise it has m rows. So we have an m cross n matrix, m cross n real matrix. Then, so we have to check which of the following options is correct. So the first is infinity norm of A is equal to maximum of I from j to n and summation of I from 1 to m aij. The second option is 1 norm of A is equal to maximum of I running from I running from 1 to m summation of j from 1 to n aij. The third option is norm of 1 norm of A transpose is equal to infinity norm of A, and the fourth option is 2 norm of A transpose is equal to infinity norm of A. So, can you tell me which option is correct? You can think over it for a minute and then tell me what do you think which option is correct.
Third one is correct. By already just discussed in the class.
Okay, yeah. So this is the
There
previous
is a
year
direct
assignment.
proof already discussed, but for others we have to once check.
Okay, for option 1, 2 and 4 you have to think, right?
Hmm.
Yeah, so let us quickly go through these options so as to check whether or not they are correct.
So
So
one
the
norm infinity,
yeah, you're saying something, Kavita?
which is the maximum of row sum.
Yeah. See, here infinity norm is given and it has been said that maximum of j running from 1 to n and summation of I equal to 1 to m and aij. Now aij is what? It is the element of the matrix, right? And here we are
Yes.
taking I from 1 to m. That means j is getting fixed, right? What does fixing of j means? Fixing of j means that we are taking column wise sum. We are fixing, say, first row, say j is equal to 1. So it means first column. And then in column, we are doing the summation, and when we do the summation of all columns from j equal to from 1 to n. So that is column sum of first row, then column sum of second row, then column sum of third row, and so on. So it is what? It is the maximum column wise sum. And by definition, we know that max of column sum is which norm? It is the
Just a one norm.
one norm, right? So the first option is incorrect. Now looking at the second option, again it is written, it is just the opposite of the first option, right? So it means that
Yes.
here they are fixing what? I, and j is from 1 to n. That means they are doing row wise summation. And row wise summation is infinity norm, not one norm. So, so these two options are written incorrectly. So this is also wrong. Now third option is correct. Why? Because we know that infinity norm is what? It's the maximum of,
Maximum of row sum.
yeah, sorry, maximum of row sum. Yeah, maximum of row sum. And while taking A transpose, we know that we are interchanging the
Rows and
rows.
columns. So
Yeah, rows and columns. So it will remain unchanged. So the one, no, when we are taking, sorry, when we are taking one norm, the rows and columns will get exchanged, and one norm is the column sum, correct?
yes.
Yeah. So that is why the column sum of A transpose will be equal to the row sum of A. So from here we can say that yes, the one norm of A transpose is equal to the infinity norm of A. And if we look at the fourth option, it is written that the Euclidean norm or 2 norm of A transpose is equal to the infinity norm of A, which is again incorrect because we know that the 2 norm of A transpose is what? We have to calculate the eigenvalues, then take their root, and which is the maximum, that is the 2 norm. But again we have seen that infinity norm is nothing but maximum of row sum. So this option is also incorrect. The third option is correct. Understood till here?
Yes, ma'am.
Okay. So now the second question. Um, yes, okay. So the second question is, let A is equal to a matrix which is of size n cross n, and all the entries are equal to 1. Like every entry is equal to 1 and it is an n cross n matrix. Then we have to check the following options. First is the 2 norm of A is equal to n. The second is 2 norm of A is equal to root n. Okay, Gifty, it's fine if you can attend the church activities. It's fine, I'll upload the recording. Okay, so third is that the 2 norm of A is equal to n square, and the fourth is the 2 norm of A is equal to 1. So basically it's talking about 2 norms, so we can simply calculate it and see what the 2 norm is equal to. So Kavita, can you quickly try this question?
Yes, ma'am. Yes, yes.
Yeah.
So, transpose Answer is second option, root n.
Root n.
Right?
I How did you approach it? It's wrong, but how did
Wrong.
you approach this
Okay.
question?
Actually, I find out A transpose A.
Mm-hmm.
Then I try to find the maximum eigenvalue. Then root of the maximum eigenvalue of A transpose A.
Yeah, but this is an n cross n matrix, and n is not defined like n can be whose. So how did you calculate A transpose A and then its eigenvalues?
Uh, Actually, I try like this: A transpose A,
Uh-huh.
which gives all the entries of
Okay.
n by n matrix with all entries n.
Mm-hmm.
So, which is a rank one matrix.
Mm-hmm.
So the eigenvalues are zeros and n
Zero
and
zero
all
zero zero up to n, right?
0 0 0 n minus 1 times, and the one more eigenvalue is the trace of the matrix. Okay. Then n times n.
Yeah, it will be.
So
Yeah,
this
you are
is
making the mistake here
n
only.
times
Otherwise, your
n.
approach is
So
correct.
the eigenvalue, one of the eigenvalues is n squared.
Huh.
So if I taking the maximum eigenvalue is n squared, take the root, the answer is n.
Yeah, the answer will be n. Correct.
Correct? Okay.
So
I
we
made
know.
a mistake in
Yeah, I understood your mistake. That's why
space.
I wanted to ask you how did you approach it. So
Okay.
we know that for calculating the norm, we can do it like this also, that A transpose A we have to calculate first, right? And we
Yes,
know
ma'am.
that A transpose A is nothing, since this is a symmetric matrix, real symmetric matrix, it will be A square, right?
Ah,
So, and we know that lambdas of, that is eigenvalues of A transpose A, let me write it this way. Eigenvalues
values of
of A transpose A is equal to eigen values of A square, correct? And that is equal to eigenvalues of A whole square.
reports. Right?
This we can write, right? And
Yes.
for A, the eigenvalues will be, since it's the n cross n matrix with one entries only, so it will be 0, 0, 0, 0, 0 up to, and the last one will be n. So now we know that we have to take the maximum of these, right? Maximum
Hmm.
of eigen values of A transpose A
Which is
is
n
equal to
squared.
n.
N
Uh,
squared.
yeah, it's square actually. Yeah, uh, n square, and it will be the norm of A is maximum of under root of this thing, maximum for eigenvalues of. Sorry, you can.
N squared.
Yeah, so it will be n square, and therefore the norm of this will be equal to n,
Yeah.
right?
Yes, ma'am.
So yeah, you did it correctly. You made just a simple mistake, and that is fine.
Yes.
But take care in examinations, right? Because
Yes.
sometimes these simple mistake and you will lose marks.
Okay.
So now let's move to next question. Mm, okay. So again, suppose we are given a matrix which is of m cross n size. Okay, that is A11, A12, A1n, and up to AM1, and so on up to AM, and sorry, it's AN. Okay, it's not a m cross n matrix. Actually, in question it is given an n cross n matrix. Yeah. So it is an n cross n matrix, and is non-singular. Okay, let A is any non-singular. So what does that mean? That determinant is not equal to 0.
Determinant not equal to 0.
Yeah, and all the entries are given real. Then it's talking about the condition number of A, that which of the following is correct. Condition number of A is equal to 1, condition number of A is equal to n, third option is condition number of A is less or equal to 1, and the fourth option is condition number of A is greater than 1. So basically first we'll find the condition number, then only we can comment on that. So can we find the condition number of this, or do you have any other approach in mind? Give it a thought, then we'll discuss the solution. See, basically what is the definition of condition number? In terms of matrix, we discussed in last class also, last tutorial, that condition number of A can be written as norm of A into norm of A inverse, correct? We can
Okay.
write this thing. And then we know that norm of A into norm of A inverse is always going to be greater or equal to norm of A into norm of A inverse. Agree upon this? And from here we can see that this thing is nothing but what? A into A inverse is a identity matrix. So norm of A into norm of A inverse is greater or equal to
1.
what is the norm of identity matrix? It will be
1.
1, correct?
1.
So from here we can see that yeah, condition number is greater or equal to 1, correct?
Okay.
Options,
Greater than or equal to?
yeah, greater than or equal to, but I don't know why it wasn't given in options. Let me check. No, wait a minute. I think there is some error in this question. No, actually this thing here. This thing here, yeah. Norm of A into norm of A inverse is less or equal to norm of A into A inverse. Sorry, here I made a mistake. This thing will be. So the option third is correct. Okay. This is a simple identity. We can prove it also, but here the proof is not important. We can just simply remember that for any two matrices A and B, norm of A into norm of B is less or equal to norm of AB. So the option third is correct. Now moving on to next question. This video. Yeah. So this is a simple question. Try to do it quickly. Let A is equal to, it is a 3 cross 3 matrix with entries 2, minus 2, 1, minus 1, minus 3, 1, 3, minus 5, minus 9. Okay. And it's a 3 cross 3 matrix. Then calculate its 1 norm, 2 norm, and infinity norm. is simple. You can
Yes.
quickly do it and tell me. Then you can do the 2 norm.
Yes, ma'am. Give me a minute.
Yeah.
One norm is 11,
Yeah. One norm
and
is one norm is simply what?
11. Column
Column
sum,
sum, the
maximum of
absolute
column.
value of the entries of the column we are taking. So you can see it's 2 plus 1 plus 3, that is 6. It is 5 plus 3 plus 2, that is 10, and it's 9 plus 1 plus 1, that is 11. So the taking the absolute values of the entry, the column sum of third row is the maximum. So that is the one norm.
Mm.
Correct. Then the infinity norm is what? It's just the
Maximum of
maximum of
rows.
row sum.
Rows.
Absolute values of the entries of rows we have to take. So
Yes.
for the first it is 5,
17,
for the second it is again 5, and for the third it
5,
is 17.
17.
Yeah. And now
Uh,
for 2 norm, we'll
One should
calculate.
give me some time.
Yeah, yeah. Take your time, then
Yeah,
calculate.
thank you.
So you continue with your calculation. I'll do the solution along. We
Mm.
know that for taking the 2 norm, we have to take what? The maximum of eigenvalues of A transpose A. So
Yes.
let's first calculate A transpose A. Okay. So did you
Mm.
calculate it?
Thanks to Norman. I'm doing
A transpose is what? 2 minus 1,
minus 1,
3
3.
minus 2 minus 3 minus 5, 1, 1 and minus 9. Correct?
Yes.
And now multiplying it with A.
14.
Yeah. What did you get the value?
14.
14 shouldn't be there. It is 9 actually. You maybe made some mistakes the second term. What is the second term you're getting? 4 plus.
Ma'am, multiplying 4 plus 1 plus 9.
Yeah, actually it should be 4 plus 1 plus. Yeah, 9.
Mm.
4 minus 2. I think there is a mistake because I have done it on MATLAB as well. A into A transpose. Are we calculating A transpose correct? Yeah, 2 minus 2, 1. Yeah, you keep on doing your solution, and let's figure out if we are making some mistake here. 2 plus 1 is 3, which is a 9. Yeah. Hmm. Okay, so what are you getting? This will be 14, right?
Yes, ma'am.
Tell me other entries you're getting.
Minus 16, minus
Uh,
26.
4
Remaining.
minus 3 is 7 and 15. Yeah, it is 22, second term.
Ma'am,
What is the second term?
minus 16,
Yeah, the third.
minus 26,
Uh-huh.
minus 16,
Okay.
and remaining now I have to do 38,
Hmm.
40,
Uh-huh. 2 plus 1.
minus 26,
Yeah, this one is minus 26. This one is
40,
uh-huh.
and 83.
This one is 40, right? Or 14.
Nice. 40, 40,
Yeah.
40, then
Uh-huh.
83.
Okay, 40 then 83, correct?
Yes, ma'am.
Okay. Now calculate the eigenvalues for this.
Very good one.
Determinant of V minus lambda I is equal to. Oh, wait a minute. Hmm. Are you getting the same equation?
No,
Simplify?
ma'am, I'm doing.
Yeah, okay. You have to still simplify it. It will be Are you getting the same characteristic polynomial? Kavita, did you arrive at this equation or you're still doing?
Proceed. I'm not. Later, I do, ma'am, this question.
Huh?
I'm not getting this answer. It takes some time.
Yeah, it
Later,
can
I
take.
check, ma'am.
Um, okay. You
Then,
can solve this equation later, but on simplification, we get this characteristic equation.
ah,
You can do it
okay,
on
ma'am.
calculator easily, right? It's a cubic
Ah,
equation. Find
yes.
the roots and tell me what you are getting the value of lambda. Up to a cubic equation, you can expect questions because the characteristic polynomial up to cubic level can come in your exams as well. I'm not sure if they will go higher than that. They
Hmm.
probably won't, but yeah, cubic you can expect in matrices that maybe sometimes you will have to calculate eigenvalues of a cubic equation. So these sort of questions might come in examination as well. So do it on calculator and tell me if you are getting the same values as me. Are you getting the same values?
Doing, ma'am.
Okay, you can do it. Now, among these three, we know that the maximum is lambda 1, and obviously the under root of the this one is only going to be maximum. So, maximum of under root of lambdas is equal to under root of 1.5.566, which will be equal to 10.750. Okay.
Okay, madam.
So this was also a previous year assignment, but there it was only given to find infinity norms. So I thought practicing on one norm and two norm will also be good. Should I move further?
Yes, ma'am.
Okay. So for the next question, okay. Um, okay. Let A is equal to 1 by 4, 1 by 2, 0 and 1 by 4. A 2 cross 2 matrix A is given. Then limit of k tending to infinity e to the power k is what? Can you calculate its value? It's very simple. In these questions, what we do? We will take limit on individual elements, right? Limit k tending to infinity 1 by 4 to the power k, which is what? 1
For
upon,
this, for each element, we have to apply, ma'am.
yeah, each element, no?
Okay. Okay, madam.
Do you remember that in case of vectors also we did similar questions
Okay, okay.
when we were
Then,
finding that where a vector converges?
hmm.
Yeah, so that similar concept has been extended in matrices. You must have studied during the week about the convergent matrices as well, right?
Okay, madam. Yes.
Yeah, so
Then,
here
so
also you
everything
can,
0.
it will be 0 for the second element. It will also be equal to
0 for
0.
everything.
The third element is 0 itself, and so what is the limit k tending to infinity a to the power k? It is equal to
is zero matrix.
So from here we can make an observation that this matrix is what? A convergent matrix, right? It was not asked in the question, but even if it's asked in the question, it comment whether it's convergent or non-convergent. You can clearly see that as k tends to infinity, this matrix converges to
Tends to
0, so it is a convergent matrix, right?
Okay. Yes.
Yeah. So coming to next question. Um, Now let U and V be two 3 cross 3 real orthogonal matrices. Okay. And A is equal to 0 alpha 0 3 0 3 0 alpha 0. Okay. Comma alpha belongs to R and 2 norm of UAV is given 4. Then okay. The
2
options
norm
are,
of UAV equal to 4 mm.
yeah, UAV का 2
Is
norm is
equal.
equal to 4.
Okay.
Alpha is equal to 3, alpha is equal to minus 3. Third option is alpha is equal to 5. And the fourth option is no such real value alpha exists. So how do you approach this question? Any idea?
Actually, UV is given as a real orthogonal matrices. So norm of UAB 2 norm which is equal to 2 norm of A.
Yeah. So you have to
So
calculate
this
2
would be a
norm of
good
A and then equate it to 4
4.
and find the value of alpha. So
Okay, madam.
you can do it along with me. I'll also do the solution.
Ah,
So you
yes.
can also proceed. So the 2 norm of UAV is equal to the 2 norm of A. And for calculating the 2 norm of A, first step is we will calculate A transpose A, which is equal to P transpose is 0 3 0 alpha 0 alpha 0 3 0 and it is 0 alpha 0 3 0 3 and 0 alpha 0 multiplication, it gives 9 0 9 0 2 alpha square 0 9 0 9. Are we on the same page till here?
Yes, ma'am.
So let's call this thing as B. So B is equal to A transpose A. Now we have to find the eigenvalues of this B matrix, which is nothing but A transpose A. So now determinant of B minus lambda I should be 0 for calculating the eigenvalues, which implies 9 minus lambda 0 9 0 2 alpha square minus lambda 0 9 0 9 minus lambda, determinant should be equal to 0. So if you calculate the values meanwhile, you can let me know. So what is the characteristic polynomial you're getting, Kavita?
I'm doing. Give me a time.
Okay, so it's, see, sometimes you don't have to, okay, you can continue, then I'll tell.
Um, Lambda cube.
Mhm. Is the screen still visible, Kavita?
No, ma'am. No, ma'am. Screen is not visible.
Okay. Now is it visible?
No.
Okay. Yeah. So here you can see, did you expand this whole thing?
No, madam.
Then how did you do it here?
Shortcuts.
Okay. That is fine because you should do the shortcuts. So here you can see that, yeah, 9 minus lambda square you can take, and see this thing you can take common from both the terms, right?
Hmm.
So it will be something like 2 alpha square minus lambda, and then it will be 9 minus lambda square minus 81, I guess, right? And it's 2 alpha square minus lambda. Then here, when you expand this, it is 81 a square plus b square minus 2ab, right? So this 81 and 81 will go. So from here, lambda is either 2 alpha square, and from this, lambda square minus 18 lambda equal to 0 implies either lambda is equal to 0 or lambda is equal to 18, right? Now
Okay,
see,
madam.
here we have been given that UAV is the two norm of UAV is what? It is 4,
One
correct?
more eigenvalue.
3 will be only there, no? It's a cubic.
What about one more eigenvalue?
You're getting one more.
I am not finished it.
Okay.
Three eigenvalues are possible. You are giving 0 and 18. What
No,
about
no,
one
here
more
also,
eigen?
na, alpha is equal to 2, sorry, lambda is equal to 2 alpha square, na?
Okay, 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 okay.
One
Sorry, sorry,
eigenvalue
sorry.
is this, and from this second equation, we are getting these two eigenvalues. From here, we
Mm-hmm.
got lambda is equal to 2 alpha square, and from here, we got lambda is equal to 2 or lambda is equal to 18, correct?
Okay, madam.
Now, see, here it is shown that UAV is UAV का 2 norm is what? 4. So that
4.
means this has been the under root of the maximum eigenvalue, correct? So from
Mm.
here we can deduce that lambda max is equal to 4 square, right?
16.
Which
16.
is 16.
But
But
here 18 is there.
here is 18 is max, so that means 2 alpha square should be greater than 18. But that is not possible because it is given that 16 is the lambda max, right?
Okay.
From here.
Yes.
So no such real value of alpha will exist.
Okay.
Such that both conditions are satisfied, there is no value of alpha, because you can take any value of alpha and it will still be that UAV2 is given as 4 and the maximum eigenvalue, however, is given as 18, right? So this term can never exceed this term and no such real value of alpha exists. Okay. So here option 4 is correct. Did you understand the solution?
Yes, ma'am. Yes.
Okay. So let's move to another question. Are you done writing or should I keep the screen for a while? You can note it down. Take a minute.
I noted, ma'am. I take
Okay,
a
note
note.
it down. So let's move to another question. Uh, this we did. Okay, a similar question. Again, let U and V be two real 3 cross 3 orthogonal matrices. Okay, the definition is given again, but here A is given as cos of beta minus sine of beta 0, sine of beta cos of beta 0, 0, 0, alpha, comma alpha, comma beta belong to the interval 0, comma pi closed interval with UAV, sorry, the Frobenius norm of UAV is given as 3. Then alpha is equal to what? Again, we have to calculate alpha here. You know that the same thing applies for Frobenius norm as well, right? That the
Mm.
Frobenius norm of UAV is equal to the Frobenius norm of A, given that U
A.
and A are real and orthogonal matrices. So quickly
Mm.
calculate the Frobenius norm for this A and then equate it to 3.
Okay, ma'am.
So we know that Frobenius norm of UAV is equal to the norm of the Frobenius norm of A. So how do you calculate the Frobenius norm of A?
Um, Square root of trace of A transpose E.
Yeah, we take the under root of trace of A transpose A. So
E.
A transpose A is what? Quickly we can calculate it. Cos beta sine beta 0
Oh.
minus sine beta cos beta 0, 0, 0 alpha. This is A transpose and A is cos beta minus sine beta 0 sine beta cos beta 0, 0, 0 alpha.
2 plus
2.
1 0 0
Yeah,
1
see
0
cos
0.
square beta plus sine square beta is 1. Here again cos
Mm.
beta sine beta minus cos beta sine beta plus cos beta sine beta, it will be 0. This term will be 0. This will be 0 in the similar way. It will be, and the second one will be sine square beta plus cos square
1
beta, which is equal to 1. This will be 0. This is again 0, 0, and
0.
this will be alpha. Correct? Sorry, alpha square. Alpha into alpha will be
Ah,
the
yes.
last element. So now A transpose A.
So,
So the trace of A
hence
transpose A is what? It is coming out to be
2
1
plus
plus
alpha
1
square.
plus alpha square, right? And this is equal to
Yes.
what? 3, correct? This has been given as, no, you can take it as root 3 here. Sorry, it is root 3, okay? It's given in question as root 3. So this thing will be 3 and alpha square will be what? Because it will be square of this thing, na? Root 3 ka square. And alpha square will be 1. Alpha will be plus minus 1. Correct? So now here, which
So,
option should be correct? There were 4 options given. Alpha equal to 1, alpha equal to minus 1, alpha equal to plus minus 1, and again alpha does not exist. So you might think that this option is correct, but no. you have to see the range also. Here clearly it's mentioned that alpha belongs to the interval 0 comma pi. So this is a very small point, but during solving the questions you have to look at this because this was a multiple choice question, and lambda equal to plus minus 1 was also in the option, but that is not the correct option because it has been mentioned that the value of alpha should be 0 to pi. So only 1 will be acceptable. Therefore, alpha is equal to 1.
Plus 1.
Yeah. So this is the correct answer.
Wait.
Now, should we move ahead?
Yes, ma'am.
Okay. Mm. Mm. Okay. So here the question is, consider the discrete non-linear system. A non-linear system has been given, a discrete non-linear system. Xk plus 1 is equal to 3xk plus yk minus xk square, and yk plus 1 is equal to xk plus 3yk plus xk yk with initial condition x naught y naught equal to 1 0. Then calculate value of x3 y3. So this is a simple question. Try to do it quickly. I'll give you 3 minutes for this and tell me what you are getting the value of x3 and y3. So Kavita, did you calculate it? X1 y1. Okay. So for I'll go through the solution. First we'll put k equal to 0 and it will give us x1 is equal to 3x naught plus y naught minus x naught square, which is nothing but 3 plus y naught is given as 1 0, and again x naught is equal to 1, so it will be 2, and y1 is given as what? X naught plus 3 y naught plus x naught y naught. Now from an initial condition x naught is 1, this thing will be 0 and this thing will be 0, so it will be 1. Now putting k equal to 1, x1 will be what? 3, x2 will be 3x1 plus y1 minus x1 square, which is equal to what? 6 plus 1 minus 9, correct? No, sorry, it will be 3, 2, it's 2, so it will be 4.
Minus 4.
So this will be what? 3,
3.
and y2 will be equal to 2 plus 3 y0. Y0 is 1, so 3 plus x0 y0. That will be what?
7. 7.
7, right? This will be 2 and it will be 7. Now put k equal to 2. x3 will be what? 9 plus 7 minus 9. It will be 7, and y3 will be 3 plus 3 into this is equal to 21 plus 21. It will be 45. So the answer is x3 and y3 will be 7 and 45. Okay.
Okay, madam.
Okay, so let's talk about the next question. Did you attempt this week's assignment?
Yes, madam.
Okay, so like similar questions would be there also, right? The
Yes,
pattern.
but I have one question in the tutorial. Sorry, in the assignment, I have one question.
Which question is that?
Question number 6.
No, actually, I don't know about this, na, the new assignment. So, what is the question exactly
Uh,
based on?
Actually, one 2 by 2 matrix A is given
Uh-huh.
and X vector also given. Then
What is also given?
then X vector, column vector.
Okay, okay, okay.
Then the question is limit k tends to infinity a power k x.
Okay, okay. So I haven't got the same such question. I haven't prepared for the tutorial. I mean, like the upcoming questions they are on now on that stability. So you can put that question in the chat box at the end. Okay, so that I can, if we'll get time, we can discuss it now also together, or
I need an
maybe next
idea
class.
how to proceed. I need an idea how to do this.
Okay, okay. At the end, we will discuss. Okay, you put the whole
Okay,
question and I'll see. Okay,
okay,
you
ma'am.
can put it in the chat box. First, let me finish this session. Okay, the
Okay.
questions we're going to discuss. Okay, so the next question is hmm, okay. Mm, okay, so consider the discrete linear system xk plus 1 is equal to axk, where a is equal to 1 by 2, 1 by 4, 3, 0, 1 by 2, 1, 0, 0, 1 by 6, with initial condition x naught is equal to x1, sorry, x naught, y naught, z naught. Then there are certain options. Ak tends to 0 as k tends to infinity, with A2 norm given as 4.1667. The second option is AK tends to 0 as k tends to infinity, with A1 norm equal to 4.1667. Okay, so yeah, so how do we do this question? Hmm? Simply you can
Norm
verify
1
if
norm
AK
2.
is tending to
Norm
0
1.
as. Huh?
Uh, AK tends to 0 as K tends to infinity. That thing, for each entries we can check.
Uh-huh.
And A1 also, the norm of A also you can find directly.
Yeah, yeah. So do it and tell me which of the following options is correct.
Uh, okay, madam. Okay. Actually, one norm of A is 4.1667. That thing is correct. But AK tends to 0
अभी
as K
एजेंट
tends
को
to
मैसेज देखो
infinity.
मेरे व्हाट्सएप पे.
For each entry, if you apply K tends to
जल्दी
0,
जल्दी.
in the first row, the third entry is 3. If you apply raise the power to infinity, which will use infinity only.
Okay, so see, you checked all of them, no? Okay, okay. So you're telling me, wait a second. You were not audible. Can you repeat again, Kavita?
Madam, actually, one norm of A is
Yeah,
4.1667.
yeah,
That
that
thing
is
is
correct.
correct.
Hmm.
But K tends to infinity. If I apply the for each entry, I raise the power to K and apply the limit tends to infinity means for the first row, third entry, and second row, third entry, which won't be 0.
Yeah, but there is another method of like that is a sufficient condition, right? Like if
So,
your all entries are coming out to be 0, there is another method of doing the same question, right? Have you studied any other method of doing this, calculating the uh, k, the a to the power k, as because this method is not feasible for higher computations. Like there is another method. I am not able to recall it right now. Can you recall it if during the lectures sir has discussed something like that? Mm-hmm. Do you recall anything like that?
no, ma'am, I don't know.
Um,
Here, real then is conversion. Actually, one theorem A is convergent if norm of A is less than 1.
Yeah, actually, yeah. If but now
But
where norm of A is not, but that is also a sufficient condition, not a necessary one. So
okay,
yeah, how we can do is that yeah, we can do it with the basic method, which is the actually the definition. For the definition, I think yeah, A is convergent only if and only if the magnitude of the eigenvalues of A is less than 1. I think that is the definition, basic definition.
okay.
Others arise from that only. The basic definition is that a matrix is convergent if
Convergent.
the spectral radius of the matrix is less than 1, or if the eigenvalues of the matrix are less than 1,
less than 1. Yes.
right?
Yes, ma'am.
Or
If an necessary and sufficient
yeah,
condition.
that is the necessary and the sufficient condition. That
Yes,
is why we
yes.
will check for that thing here. Since this is an
Hmm.
upper triangular matrix, there is one thing special. We know that the diagonal elements are the lambdas or the eigenvalues.
Eigenvalues.
Otherwise, you will have to find the eigenvalues. If it's not given a triangular matrix, you will have to find out the eigenvalues. So here you can see the lambdas are equal to what? 1 by 2,
1 by 2.
1 by 2 and 1 by 6. And all of them are less than 1,
Yes.
correct? Even the
Yes, ma'am.
maximum among them is this, so it is 0.5, but it is less than 1. So that is why it is a
Hmm.
convergent matrix. Okay. So this thing we can put
Okay.
from here, and 1 norm, 2 norm we can simply calculate. So the second option is correct. Okay.
Okay, ma'am. Yes,
Yeah.
yes.
So now what else should we discuss here? Hmm. Okay. So consider the system xk plus 1 is equal to 2xk plus 4yk plus xk square yk cube. We discussed the previous question here, right? That was similar, but here, okay, here also it was a non-linear system. So here again we have been given a non-linear system which is defined as like this, and yk plus 1 is equal to minus xk plus 2yk square plus 3xkyk. Okay, so check if the point 0 comma 0 is locally stable or not. Okay, so this question is related to stability. That is the last lecture of week 7, right? So
Yes,
for
ma'am.
this non-linear system, we have to check whether this point is locally stable or not. So how do we approach this question?
First, to form a matrix A,
Huh?
here linear part also there. So, by considering only the linear part, we can form a matrix A. Then
Uh-huh.
find the norm.
Only the linear part.
Yes, because that from form a matrix A, your system consists of linear and non-linear part, both the things. So, direct consider our linear part alone, we can make a matrix A.
I'm not sure
Or
about
else we
this.
do the partial derivatives, the
Yeah,
Jacobian,
yeah, we
that
can do
thing
it
we
that
do
way.
itself.
But if you want, you can do it
Intersection.
the way you said, and then we can match the solutions, right? To check if both the way approach we are getting the same answer.
Only the system involve the non-linear terms.
Uh-huh.
We use the Jacobian format, but it
Yeah,
is
yeah.
a
So here
combination
there
of
are non-linear
linear
terms.
and
So
non-linear.
yeah. So first you will do one thing, you will form a Jacobian matrix for this, and then
Okay.
substitute the value 0, comma 0 there. And
Hmm.
after substituting values, the Jacobian matrix you get, you have to find the eigenvalues for that. And
Hmm.
again from that finding the eigenvalues, then we can like say comment about the stability. If the eigenvalues are greater than 1, then the system is the absolute value of the
Spectral
eigenvalues is
radius.
greater than 1, the system is stable. If it's not so, then the system is not stable. So first we will form the Jacobian matrix. Okay, so here
Okay.
Yeah, solve along with me and tell me what you are getting. F of x comma k and
2,
y
4
comma k
minus
is
0.
2xk plus 4yk plus xk square yk cube and f2 is equal to minus xk plus 2yk square plus 3xk yk. Okay, now Jacobian is what? Dou f1 upon dou xk, dou f1 upon dou yk, and similarly dou f2 upon dou xk and dou f2 upon dou yk. Now this we are getting as 2 plus 0 plus 2xkyk cube, 0 plus 4, okay,
4 plus
plus
3.
3xk square yk square, right? This is minus 1 plus 0 plus 3yk, and this is 0 plus 4yk plus 3xk,
Okay.
correct?
So my answer is 2, 4 minus 1, 0.
Yeah, the final answer is what? 2.
2, 4 minus 1, 0.
Yeah, that is correct. So now here Jacobian of 0 comma 0, while substituting that we get 2, 4 minus 1 and 0.
0.
Now what we do? We find
Eigenvalues
the eigenvalues
minus 1 and 4.
of j at 0 comma 0. So you calculated eigenvalues?
It's an upper triangle matrix, so minus 1, 4.
No,
Correct.
it's not a triangular matrix. No, 2, 4 minus 1 and 0 is there. You have to see diagonal like this, not like this.
Okay, 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 okay.
So you have to calculate. You have to
Lambda
calculate it
square.
like j
Mm.
minus lambda I determinant equal to 0. Did you calculate?
Yes. Lambda square minus 2 lambda plus 4 equal to 0.
Yeah, it will be 2 minus lambda into minus lambda plus 4 equal to 0. It's minus 2 lambda plus lambda square plus 4 is equal to 0. So what are you getting?
Yes, the same. Eigenvalues 1 plus or minus root 3i.
Yeah, it will be complex.
Mm. So the modulus of the eigenvalues we get 2 is greater than 1.
Yeah, it will be
So the
minus 12
answer
by
will
2 and lambda here is 2 plus minus 2 root 3 I upon 2. So lambda is what? 1 plus minus root 3 iota. Okay.
be
So
yes, ma'am.
lambda 1 is 1 plus root 3 iota and lambda 2 is 1 minus root 3 iota.
I
So what is the magnitude of lambda 1? It will be 1
2.
square plus root 3 square ka root, right? Which will be
Yes, madam.
under root 4, which will be 2. Okay,
2.
2 plus or minus 2, but you have to take absolute values of 2. And here also it will be same.
2.
Correct. Lambda 2 will be 2. So here we can say
Yes.
lambda 1 comma lambda 2 is greater than 1. So the system is locally unstable. Okay.
Unstable.
The system is locally unstable at 0, 0. So it's point dependent, right? At this point it is unstable. At a different point it can be stable as
Stable.
well. Okay.
Okay.
So I have reached the end of the questions. Okay. I think this much is sufficient. Now you can tell me the question you were telling. What is the question?
A is equal to,
Okay, let me write it. So let A is
let
equal to
A is equal to
uh,
1 by 3,
uh-huh.
1 by 9.
Okay,
Next row, 0,
okay. It's 2 cross 2.
1.
Okay.
Yes, ma'am. 1.
Mm.
That's all.
So,
Belongs to M2 by 2 of R. And
okay.
let
Uh-huh. Wait a second. And let
X is equal to
hmm,
uh, column 1, 12.
uh-huh, 1 and 12.
12.
So it's a vector. Okay.
Yes, ma'am. Then
Uh-huh. Wait a second. Then
limit k tends to infinity,
uh,
a power k
a power k
into x.
into
A
x
power
is
k x
uh,
is the answers.
okay. Then there are options given, right?
Yeah, yes, ma'am.
What are the options?
First option doesn't exist,
Uh-huh.
and the remaining are exist and equal to some answers given.
Exists and value of
And equal to
okay equal to something. Okay.
212.
Okay. Let us find
Okay.
this whatever this is. Okay. So okay. Uh, Now that we are given that the matrix A is equal to 1 by 3, 1 by 9, 0 and 1, and x has been given as 1 and 12. And the question is asking us about uh, the value of a to the power k x as k tends to infinity, right? Now we can see that this is an upper triangular matrix, and the eigenvalues, we all know that eigenvalues of an upper or lower triangular matrix is equal to the diagonal entries. Right, and here the entries are 1 by 3 and 1. We can clearly see that 1 by 3 is less than 1, but the second value of the second eigenvalue is not less than 1. Had it been strictly less than 1, right, we know that this matrix is convergent. Correct. Now, since here it is equal to 1, and that is why for checking the behavior of a to the power k into x, we'll use a different approach. So, in previous lectures, you have studied about the process of diagonalization. So, we can approach this question with that thing also. We will diagonalize the matrix a to the power k, right? And we will find the model matrix P, then we can write A as P into D to the power K and then into P inverse. So that is how we can like find any power of the A, and then we can multiply it with the vector x to check the behavior. Okay, so therefore the first step for diagonalization, we know that we will first find the eigenvalues, and eigenvalues are clearly given as 1 by 3 and 1. Okay, let me write it as lambda 1 equal to 1 by 3 and lambda 2 is equal to 1. Now for lambda equal to 1 by 3, we will find A minus lambda 1 I into V1 equal to 0. Okay, we'll find the eigenvectors first, only then we can form the model matrix for the P. Okay, so again V1 we can take as something alpha 1 alpha 2, right, and it will be 0 minus 2 by 9, 0, 2 by 3, then alpha 1 alpha 2 is equal to 0, 0, right. Now here 0 into alpha 1 minus 2 by 9 into alpha 2 is equal to 0, and 0 into alpha 1 plus 2 by 3 alpha 2 is equal to 0. From here we can see that this implies what? Alpha 2 is equal to 0, correct, because we cannot say anything about alpha 1, it's already multiplied by 0. So alpha 2 is equal to 0, and here also alpha 2 is equal to 0. So for sure V1 is equal to alpha 1 and 0, and we can write it as alpha 1 into 1 and 0. Now putting alpha 1 as 1, we get V1 as 1 0, right. Similarly for lambda 2 equal to 1, we will again form a vector, say first we'll do like A minus lambda 2 into I times V2, vector V2 is equal to 0, and V2 can be written as something beta 1 and beta 2. Now it is the same procedure, and you have done this like multiple number of times. I will not do this procedure here. We will ultimately reach at V2 equal to something like beta 1 into 1 and 6, and here I choose beta 1 is equal to 1. You can take any other number as well, and it gives me beta 1 is equal to 1 and 6. Okay, understood till here? Now you know by the definition of modal matrix, P is equal to what? Nothing but the vectors of the the eigenvectors for the matrix A written in the column wise form, which gives me something like 1016. Okay, and the diagonal matrix, we know it is nothing but all the diagonal entries are the eigenvalues of the vector, all the diagonal entries of this matrix are the eigenvalues of the matrix A, and rest are 0. So we write it like this. Okay, so I hope it's clear till now. Now we know that A is equal to P D P inverse. Okay, this we know previously, this we have studied previously, and therefore A to the power k is what? P D to the power k and P inverse. Okay, now A to the power k into x is P D to the power k P inverse into x, correct? Now solving this, it gives us 1106 into lambda 1 to the power k 0, 0 lambda 2 to the power k, and P inverse is 1006 inverse, right? And the vector x, which was given to us as 1 and 12. Now here we know that lambda 1 is what? 1 by 3 to the power k. Okay, 0, 0, and 1 to the power k is nothing but 1, so I'll write it as 1. Now calculating inverse, here it's simple. For a 2 cross 2 matrix, you know how to calculate inverse, and now here it is again 1 and 12. Now see this thing, let's keep it as it is, this thing again as it is, and the multiplication of these two will give me -1 and 2. Okay, here again, yeah, I will multiply all these three, okay, in order, and you will get something like this. Okay, you can check it, you can multiply this matrix and this matrix first and then with this, or whatever way you like, because it's associative. So no, sorry, yeah, you'll multiply this vector with this matrix first and then the resultant with this thing, the resultant vector with this matrix. Okay, so now taking the limit k tending to infinity, a to the power kx, it is nothing but limit k tending to infinity on this thing, correct? And you know that you can write it as limit k tending to infinity. Okay, you can do it for in a vectors, you already studied that. You can take the individual limits. Now here you can see limit k tending to infinity, 1 upon 3 to the power k, 3 to the power infinity is infinity, and 1 divided by infinity is 0. So this term will be 0 and the constant 2 will remain unaffected. So this thing is 0, sorry, 0 plus 2 it will be, and here it will be 12. So this is 2 and 12. So limit of k tending to infinity, a to the power k, x is this. You can also verify it on MATLAB. So yeah.